Welcome! In the next couple of minutes, I will show you how you can use the DVTI camera to record stellar occultation. This laptop is connected to my mount and to the DVTI camera with a USB cable. I use the software Occultation for planning and preparing the occultation observations. Tonight I have two occultations on the list. The next one is in 17 minutes and another one in 3 hours. To start, I open the DVTI camera control software and import these events into this software. I click on the blue occultation events button and get this pop-up dialog with a list of all events in the software. To add new events, I switch back to Occultation, right-click on the event that I'd like to record, and click Forward Event to DVTI Cam Control. If I do that, the event appears in this list. Let's add these two events. Okay. Now all data about these events is available to the software. I can click on a specific event to get more information, like for example, the maximum duration, probability, combined magnitude, magnitude drop, and more. And important thing here is the time, the countdown timer, 15 minutes until center of occultation. Okay, let's quickly switch back to Occultation to see where in the sky this target star is located. I use the C2A planetary software for this purpose. This is connected to the telescope. I see a red circle which shows the telescope position, and yellow crosshairs which indicates where the target star is located. So let's move the telescope to the target star. Click here, center, and zoom in a little bit. Maybe switch to the catalog with more stars. Okay, let's move the telescope to this position. It takes a couple of seconds. You see the telescope is moving, and after a couple of seconds I should see the red circle. And here it is. Okay, let's switch on the camera. In the camera control software, I press this green connect button to establish a connection to the camera. I make sure that I have selected the correct location, observer name, telescope, and mount, and then I can click this start streaming button. And now we get a live view of what the camera is actually seeing. It's quite dark at the moment. Let me check. 100 milliseconds exposure time. Gain is set to 30 dB. High gain mode is enabled. Here at the top I can see a histogram. With a single click with the left mouse button, I can position this left border, and with a right click I can position the right border, and now I can see a couple of stars here. Let's see if we recognize something here. I'm not sure. There is a plate solving functionality in this software. If you click this black button and then start, the software will record a single fits image and send it to a local instance of ANSVR. And after a couple of seconds, we get a result. And we can use this result to synchronize the telescope. Okay, now the red circle should correspond to the exact telescope position. Let's see a little bit. The side of the target star. I move manually to the target star. Okay, a little bit north here. Zoom in again. The orange rectangle corresponds to the field of view of the camera. And if we switch back, these two bright stars are here. It's horizontally mirrored, I believe. So I can click this button and now it should be all right. Yep. Okay. Let's see which one is the target star. Here, let's move up a little bit. Yes. Ten minutes to go. I center the target star in the field of view. We have these red crosshairs, which we can show and hide by clicking on this checkbox. It's very useful to center the target star. Okay. Let's zoom in a little bit. This drop-down box, we can switch to aspect scale. We can select the zoom factor here to zoom in on the target star. Okay, we can reduce the exposure time a little bit. Let's go to 50 milliseconds. Okay, that should be fine. And another thing we can do to improve the image quality is to switch on a dark frame. I have some pre-recorded dark frames here, 50 milliseconds to remove the hot pixels. Okay, let's zoom out. Good. So now we are ready for starting the recording. You can see here at the bottom that we have a valid date and time. Every frame gets a start and end time stamp here. We have a valid satellite position, accuracy 3 meters, and here we can also see some information about the camera settings. Now it's 8 minutes and 40 seconds until the event. We have different options for recording the video file. The preferred option is ADV. ADV is a relatively modern video format developed mainly by Risto Pavlov and especially for recording occultations and other astronomical events. It includes a start and end timestamp for every recorded frame, and in addition also a lot of metadata fields. And one big advantage compared to the older SCR format is that if your software crashes during the recording, which we don't hope, of course, but if it crashes, you'll still have all the timing information in the recorded frames. In the SCR format, the timing information is written at the end. So if you have a crash in the middle of the recording, you lose all timing information. A third option that we have is to record FITS series. Maybe if you have specific scientific software that you want to use, the FITS format is very in widespread use. But I recommend ADV. ADV is also supported by Tangra and PyMovie for the later analysis of the recording. Okay, now we are 6 minutes and 50 seconds away from the event, and we can now set up a timed recording by clicking on this orange button. Now we get here this pop-up window. I can select the format, in this case ADV. I can copy the event into the window. You can see here 22:46 UTC corresponds to the center time of the event. I can specify a duration of the recording, 60 seconds. That means 30 seconds before center time, the recording starts, and 30 seconds after this time, the software automatically stops the recording. Now we are good to go. I click on this start button and get here this countdown timer. Let's center the star a little bit. The telescope is not perfectly polar aligned, so I have to manually correct from time to time. This is the target star. If I move the mouse pointer over the target star, I get this special cursor, and I can see the signal above noise in this little window here. Let's do it again. You see the star brightness is 3,900, 4,000 units, and the noise floor is at around 2,600, around that. So this should be easy to analyze in Tangra or PyMovie. Maybe I could even go a little bit down with the exposure time, but let's keep it like this for the moment. We have 240 seconds left, and we just wait until that moment. Move this a little bit away so that we can see the target star. This one is not needed for a moment. Okay, let's wait a second, or a minute or two. So we are now about 20 seconds away from the start of the recording. Ten seconds. And now the recording has started. You see here at the top left this recording indicator. It's now about 20 seconds until center of occultation. 15 seconds. 10. 3, 2, 1, 0. Okay, this was probably a negative event. The recording continues until 30 seconds after the center of the event. We are still recording. 10 seconds to go. 9, 8, 7, 6, 5, 4, 3, 2, 1, stop. Okay. And the software has now created an ADV video file. And let's have a quick look at the video file in Tangra. I switch off the streaming for a moment. Open an instance of Tangra. Open video file. Should be this one. Yes. Okay, this is the target star. Let's use this star as guiding star, second guiding star, and start. This takes a couple of seconds because we have a frame rate of 20 frames per second times 60 is 1200 frames. Okay, now Tangra has analyzed the frames and lets me select the camera. I click OK and should get a light curve. Let's remove this bright yellow comparison star. Okay, run a quick reprocess on the target. Yeah, and then normalize. Oops. Doesn't change much. Okay, the blue one is the target star. We have 5,000 units, so it's clearly above 0 and there is no drop, so this is a negative. Now to create the SODIS report, I return to this software, open the event, and I say here non-detection, and I'll specify the temperature. This was about, let me check, -3 degrees Celsius, no wind, clear, steady, and create a report. And now this is the complete report, and thanks to the settings that I have configured here, I have everything in the report. It's ready to upload. Thank you for watching.